soon as it's ready. Okay. All right, so it's recording. All right. So a couple of questions I've been getting related to the midterm assignment. Go ahead and pull this up. So, okay, here's kind of what the expectation is here. So what the midterm exam is going to be basically you showing your contribution and your understanding of your group project. So you can do this in any of the formats. You can upload a Microsoft Word document or a PDF. One example I saw in the video explaining to the students how to upload something, the instructor made a single like text document or a Microsoft Word document, something like that, with like a link to a Google document. So make sure that's shareable. And they just basically pasted a Google Drive link into a Microsoft Word document and uploaded that. You know, so that's those are all good options. Okay, so that's what I expect. You know, it should be it should be a couple of pages worth of text that you're going to be writing, and you need to tell me what part of the project you were responsible for and how were you able to complete the associated tasks. What tools did you use? What new things did you have to learn? What process did you follow? Right, and yeah, so ideally you would like to have this be a couple of pages, but it at least needs to be one full page of typed text. And let you know, you don't, that's not one full page of typed text with the font size being like 58. Okay, that's one full page of typed text at a normal font, like a 10 or a 12-point font. Okay, and so there's 5 parts that is each worth 20% of this exam grade. And as I explained on Google Classroom, if I can I'll pull that up. Or basically your midterm exam is just going to be, let's see, it's going to be your assignments and your midterm put together. Okay. Your assignments and this document you're making put together will be your 40% grade that's going to come into that's going to be posted on OBS. Okay, so you need to have an explanation of your contribution to your project, your individual contribution, a listing and a brief description of the tools you used, obstacles you had to overcome, like what didn't go according to plan, like what did you think I'll do it this way, and then when you actually went to go start making things happen, there were problems that had to come up, and what did you do to solve that? What new things did you learn that you didn't know before this project? And then this part, a listing of all your group members, including yourself, and how much they contributed. So basically it's, it was the 4 of us, and this person did 20%, this person did 30%, this person, and it needs to add up to 100. Okay, so what percentage of the project did each group member accomplish? Okay, and this is purely for you. This is purely an objective thing. It's not like I'm not looking for, well, this person did 23.5% of the project. I'm not looking for an exact number like that. It's just an estimate. Okay, so. And the truth is, you will probably have different understandings of how much you did versus how much someone else did, right? But if there was a particular group member that did not contribute much to the project, that came up with excuses, didn't come to the group project meeting, this would be where you would say that. You would tell me that this person did not do as much as we had hoped they would have, okay? The midterm grade will be based on the quality of the group project to some degree, because your group project, your final group project, is actually going to be entirely rolled into that final exam grade. Okay, but this submission is also going to be factored in. Okay, so a couple of things that I want to say is that if it's determined that you and somebody else, if you basically just had somebody else type up your submission, or if you uh, just just straight copied it from someone else, then you're going to receive a 0 for the midterm exam grade. And when I say that, I don't mean this. I don't mean that you will get a 0 for this part, that you're not going to get a 0 for this 20%. Basically, what you're going to get is you're going to get a 0 for the entire 40%. So even your assignment grade will be impacted. Okay, so don't do that. All right. Also, if you claim that all group members did the exact same amount of work and we all worked on the project, for example, like it was 5 of us and we all worked together and we all did everything and we all did 20%, basically that's not possible. And so you're going to get a 0 for this bullet point if you try to claim something like this. I want you to do a really good job of assessing, really thinking through, what did you contribute to the project, what did other people contribute to the project. Okay, because hopefully you worked hard on it, and in an ideal world everybody would do equal amounts of work, but I understand that not everybody has the same amount of time to be able to put into a project like this. Okay, and so if one particular group member had more impact, did more work on doing some of the research or doing some of the query writing, then they should be reflected, and we should see that. Okay. Let's see. There was something else I wanted to say in this that I was going to pull up. Let's see. Oh, that's right. I wanted to come over here. All right, so let me share this too now. All right, so I posted this on the Google Classroom, and hopefully you all saw it. So basically what we're going to do is, because you have been doing assignments, and because there was one more given this week, there was one more posted, assignment 4. Let's see, and its due date, I'll come up here real quick. Due date May 11th. Okay, that's good. All right. So I wanted to make sure it was early enough for me to put this into there. Okay, so all of your assignments and all of your quizzes are going to basically add up to 50%, half of your midterm grade of what is going to be on the OBS OYS system. And this midterm assignment that I just went over is the other half of that. So that together is 50 plus 50. That's a total of 100 points. And this 100 points represents 40% of your final grade. Okay. And then what I'm going to do is we're also going to give some kind of final exam on OYS. And as soon as the university determines how that's going to happen, then I'll post something along those lines. All right. And your total group project, submission 1, submission 2, and presentation, plus that final is going to be half, and then the other half is the final exam thing on the OYS system. Okay. All right. So then that makes a total of 60% of your grade. Let me also clear up something else. Let me also talk about something else. I've had a couple people ask me about this whole presentation thing. There's a number of you who are in a situation where you don't have access to high-speed internet, you don't have access to consistent internet, so you're not able to join these lectures. It's obvious that some of you are not able to get here. There's only 2 students here now, for example. So the question has come up of what are we going to do about that, because what I want to do is I want to have you present live on this Microsoft Teams app. But I also want to be sensitive to those who can't do that, who have to not be able to join this, but have to instead watch the video, like download it and watch it later, that kind of thing. So here's what we're going to do is if you want to record a video and of your group members, and what you can do is, if you're concerned about the whole live streaming thing, that you don't have consistent internet to be able to do that, then what you can do is you can record videos. Each of you can record your part of the presentation, and then share it with each other, and then have one of the group members use some type of video editing tool. Microsoft used to have this Movie Maker app that was okay for something like this. I don't know. I'm assuming they still have some kind of app on Windows 10 if you're using that. If you're using a MacBook, iMovie or what is it, QuickTime, those should both be able to be used. And I know lots of people that make videos like this and edit them together using free phone apps. So I'm not looking for high quality video. I'm not looking for you to make an HD video of you guys presenting and having this like super fancy demo going on. I just want to see each group member prepare and present what they did for the project. And so what we'll have to do, though, is, in order to make it fair to everyone, if you are in that situation, and I emailed one of the groups back about this that asked this question. So we're going to start here on Monday, a week from today, May 4th. We're going to start doing our group presentations on that Monday. If you cannot join this meeting, if you cannot have consistent enough access to internet to be able to join this meeting, and you want to make a video instead, you have to have your video ready and submitted by the start of class by 1:30 on Monday, May 4th. Okay. If I do not receive that video, if I don't have, you can share a Google Drive link if you want to upload it to Google Drive. I'm sure I can set up another way. There's actually another way using Dropbox that I can also set this up. And I'll do that today or tomorrow. And so anyway, if you want to use that option, you have to have it here by Monday at 1:30. If I don't, then your group will be considered as one that I could randomly choose to be able to present that day, to present that Monday. Okay. And any group that's not ready on Monday, if I randomly call for your group to present on Monday and you're not ready and you don't present, then that will be considered a day late. And then your whole group will lose 10% off of that grade for being the day late. And remember, according to the syllabus, so this will act like the syllabus, right? So what we'll do is we'll do presentations on Monday, Thursday, then the following Monday and Thursday. Okay. Any day that I call your group, my program randomly chooses your group, any day that happens and you're not ready and you don't present, that'll be considered a day late. You will lose 10%. Remember, 2 days late is 20% off, and 3 days late. So if you somehow through the random program I'm going to write, if that chooses you 3 days in a row and 3 days in a row you're not ready, then what's going to happen is after that third day, it just won't be accepted and you won't be allowed to present, and you'll get a 0 on the project. And I really don't want that to happen for you. So if you intend to present on this video call, be ready on Monday, just to be safe. Okay. And again, that's the presentation. That's not the project report. That's your submission on Google Classroom. Your project report submission on Google Classroom, let's see, that is due, what day did I make that? Just make sure I want to tell you right. It's due May 18th, so it's due the last Monday of the semester. Okay, so you have until May 18th to do the report, but I greatly encourage you to be ready to present a week from today on Monday. Okay. Hopefully that clears up a lot of the questions that you guys have been having about the midterm assignment and the group project submission. I haven't gotten any other questions about assignment 4, so hopefully Hopefully that means you've been reading through it and you understand basically what I'm asking for, and hopefully it does not mean that you have not looked at it yet at all. So go ahead and get started on that if you have not. Everything that we, let's see, everything that shows up in that assignment, we should be done with today. Yep, I think we should be done with that today. Okay. All right. Well, let's get to it then. Let's go ahead and get to logical database design. All right. So we started this right last. So basically the idea here is conceptual database design was we're taking this idea of what we're trying to develop and we want to make an ER model out of it, right? That was the output of the conceptual database design, was the ER model. And remember, one of the things I said, was that for each of these phases, the output of one phase is the input to the next. So what we're going to do here is for the logical database design, we're going to take that ER model from the conceptual database design phase, and we're going to use it to determine how we can kind of make relations, and we're going to validate them using normalization. So normalization is going to come in as a part of this process, right? And we're going to make sure that, we're going to make sure that it works well for our users, okay? One of the optional steps here is going to be this merging step. We're going to merge two databases possibly together. It's optional because some systems are so small that we don't divide them up into their different parts to develop them. But some databases are so large, some systems are so large that we divide tasks up. You know, in a sense, even your group project was large enough that you probably divided tasks up, that you probably didn't all try to make all the database, right? You probably divided your tasks up to each do a part of it. So imagine if you had a database system so large that even the parts of the database had to be divided up and all of the process of development had to be done on all of it. Okay, so then we need to take those things and move them back together. Okay, make them into one large system. Okay. All right. All right. So one of the things that we want to do is we want to determine how to create relations from that ER model, from the conceptual model. Okay. Because remember, we don't call them relations in an ER model. We call the E stands for entities. So entities are going to become relations. Somewhat. Okay, for the most part, most entities in our ER model will become relations, but there are some exceptions, and we'll talk about that. Okay, the R in ER model stands for relationship, which is not the same as relations. Relationship is how two entities are related to each other. Okay, so what we want to do is we want to take our ER model and we want to know how to create relations, tables, from that ER model. So if we go back to our conceptual model for the staff, right, where we had this was what we came up with at the end of our conceptual database design phase. Remember, this was our example where we added those extended techniques, right, the expanded ER modeling techniques, where we have the generalization here and then the generalization here as well. Remember, this got rid of our recursive relationship. This got rid of that that problematic relationship between private owner and business owner that where we had to have a one relationship, but it was really had to write these little notes in there to say, oh, but this must have one of these but not the other, and stuff like that. Okay, so if this is our final conceptual ER model, we want to know how are we going to take this and make relations out of it. Okay. All right. Some things are easy. There's a saying that we call the low-hanging fruit. So the idea is if you come upon a tree, like an orange tree or an apple tree, and you want to get an apple or you want to get an orange off of that tree, right? You're not going to go and reach up to the stuff at the very top. What you're probably going to do is you're going to try to grab the stuff that's like right there at eye level first, right? You're not going to go through a lot of work to get stuff if there's some easily available. Okay, so this idea of the low-hanging fruit is let's take care of the easy ones first. Let's talk about the easy ones first. All right. So if we have a situation where in a relationship you have a strong entity type and a weak entity. Okay, so in one relationship you have a strong and a weak entity. All right. All right. So for each strong entity, we're going to create a relation that includes just all the attributes of that entity. Okay. We'll talk about composite attributes later. All right. For each weak entity, we're going to create a relation that includes all of the attributes of that entity, and then we're also we're also going to make a primary key from the owner entity. Okay. All right. We'll get to that in just a moment. All right. But probably the easiest one to explain is this one-to-many relationship. Okay, so basically on the one side of the relationship, so if we look at the example here, and I have this slide show up a few times because when I'm lecturing, I don't have it like this. You just see one slide at a time. Okay, so here, right, you have a one-to-many relationship. This would be an example of a one-to-many relationship. Staff to property for rent, owner to property for rent, property for rent to lease, okay, supervisor to staff. These are all examples of one-to-many relationships. Okay, so how do we take care of a one-to-many relationship? This is the easiest one of all. What we do is we take on the many side, right, and we put there's a special attribute that's a foreign key back to the one side. Okay, so on the many side, right, we put a foreign key back to the primary key over here. So in property for rent, it doesn't show up on our diagram, but what's there in our relation that we're going to create for the property for rent table is there will be a foreign key for owner number. There will also be a foreign key for staff number. There will be, we'll talk about the many-to-many relationship in a second because we don't do this way for the many-to-many. Okay. For staff, there will be a foreign key back to supervisor. That's the staff number that's supervising them. Okay. Other one-to-many relationships. Okay, lease. Lease has a foreign key that's going to point back to property for rent. It's also going to have a foreign key that points back to client number here. Okay, we put in here. We don't see it in the diagram, but there's a column. There's an attribute that's a foreign key back to the parent table. Okay, so that's how we handle the one-to-many relationship. Very easy, simple. All right. Now, what about a one-to-one relationship? Because we do have that. We have this one-to-one relationship over here. Okay, a client has a preference. Okay, well, there's a couple of different possibilities of how to handle that. We need to consider the three different possibilities. One is mandatory participation on both sides. It means that, so this would be an example of a mandatory participation on both sides relationship. A client has a preference. Preference must have a client. So a client has one and only one preference. A preference has one and only one client. Okay. All right. So that would be mandatory participation on both sides. Mandatory participation on one side, but not the other. It would mean that maybe a client must have a preference, but a preference doesn't have to have a client. You know, something like that. Actually, that wouldn't make any sense. You could say a preference must have a client if it exists. A client does not have to have a preference. They could just want whatever they want. All right. So that's one option. Optional on both sides. Okay. Which would mean It's a one-to-one relationship, so it would be 0, dot, dot, 1 on each side of that relationship. Okay. The From the last set of slides from the conceptual database model, the example I'm thinking of is that that man and woman married to relationship. It's optional. It's one-to-one. It's optional participation on both sides. Okay. So how do we handle these? Well, mandatory participation on both sides is easy. Basically what you're saying is that here's a table that has a set of rows representing a client. Here's a table that has a set of rows that represents a client's preference. So if it's one-to-one mandatory on both sides, then what that means is that you can't have a client without a preference. You can't have a preference without a client. Why are these in two separate tables? Right? So we just merge that into the one table. Let's not keep a bunch of extra columns in another table. So one-to-one like this, mandatory, merge this into one table and you're done. Okay. Mandatory participation on one side, all right? We identify the parent and child, right? And which one is the parent? All right. Okay, the entity with the optional participation is designated as the parent, and an entity with mandatory participation is the child. So a copy of the primary key of the parent is placed into the relation representing the child. What that means is if over here we had a client could or could not have a preference, if they do, all right, if a preference exists, it must have a client. This would be if this was changed from 1 dot dot 1 to 1 dot dot 1 would be 1 dot dot 1, 0 dot dot 1. Okay, optional participation on the preference side. So what that would mean, we always have to have a client, and then we just have a preference that if it exists, if it happens to exist, then in that row we put a foreign key back to the client table. Okay. Optional participation on both sides. This would be that man-woman married to relationship. Okay. Unless we can find out more about the relationship, right? Then do we put a primary key? Do we put a foreign key on the woman side? Do we put a foreign key on the man side? It depends. All right. This one, we need to know more about what we expect the data to look like. If this was a database that existed of a lot of what would it be? A lot of unmarried men, but a lot of married women, then what you would probably do would be put a foreign key into the foreign key column and onto the woman table so that you reduce the number of nulls. Okay, that would be one possibility. But the main thing is you got to find out more about the nature of the data before you can make a decision on that one. Okay. All right. Moving on. So our model again. Okay. One-to-one recursive relationship. It's the same thing again as the one-to-one with normal relationships. Okay. You just if it's mandatory on both sides, right? You just have two copies of the primary key, one that points back to the supervisor or whatever it is. Okay. All right. All right. This one is where things get a little bit interesting. This is one of the ones that gets a little bit interesting. In fact, I'm going to come back to this one because this is expanded stuff. Let's see. Okay. I want to talk about the many-to-many relationships. Okay. Because this one's sometimes difficult for some of us to see why it works this way. But basically, one thing I've said before is that usually we'll see if there's a relationship that has attributes, it'll belong to a many-to-many relationship. And here is why. Because the way to resolve a many-to-many relationship in an ER diagram, when we start building relations, is we put a relation between the two that exist, okay? So here, the property for rent table and the client table, they have a relationship. A client can view many properties. A property can be viewed by many clients, right? And so we keep track of these other attributes for when did the client view it, what did they comment, if they commented on it, right? So what we do here in our final database, what we do here as part of the logical design phase is we create this third relation between the two of them, okay? We might name it something like the client property table or the client views property table, or we can name it all kinds of different things, right? But basically it represents the intersection between these two, okay? And so anytime that a client views a property, an entry gets put in that table, okay? And what happens is the primary keys from each of these tables, the combination of those two, the combination of the client number with the property number becomes the primary key for this table, okay? With the possibility that we could add another column to make that primary key. So for example, if a client were to view a property twice, the view date might get added in as part of the primary key, okay? But basically, anytime that a client views a property, that gets seen as there's an entry in that table. So every time we see an entry, it represents a linking of these two tables of information. So the property being viewed by the client, okay? All right, so let's go back. Let's go back to the expanded, the extended UML stuff. So superclass, subclass. So basically the thing is that there's 4 different ways that you can that these can be represented, right? You have mandatory or, mandatory and, optional or, optional and, right? Those are the 4 possibilities, okay? So we need to handle each of them differently because they each mean different things, okay? So if we look at it like this, okay, so here, if we have a mandatory and, okay, what that means is that, let's see, mandatory and means that it must be one of these, it can be more than one, right? So if we had, let's see, person, and then let's say for our university system, we had a person that was a student, but could also be an employee. That would be mandatory and, okay? All right, so how do we do that? We just make that into one large table, okay? The thing is, we don't know for each row, is it going to be a specific one of these? We don't know, is it going to be all of them, all of these subtypes, okay? So we just make it into one relation, okay? So that's if it's mandatory and, okay? Optional and, meaning it could be one of those. If it is, it could be more than one, okay? Then we need 2 relations, okay? One is for that superclass, for the parent class, okay? So because everybody is going to be one of those. So if we look at this, staff, right? Everybody in our system is a staff person. Every person that we're keeping track of in here is a staff. Some are going to be supervisors. So we don't want to have to store a bunch of nulls for everybody who's not a supervisor, right? So optional, we have one relation for that one table for that superclass, and then one relation for all of the others together, right? Because which one are they? So which one of those things are they, or which 2 of those things are they, or whatever, okay? So one for the superclass, one for all of the subclasses. So Here, because mandatory, because if we have somebody that's a part of the parent class, they must be a member of at least one of the subclasses. We know that data will exist down there in the subclasses for everybody that we have in that database, right? So that's why we make it into one single relation. Optional, because you could have somebody who's part of the superclass but not part of any subclass. We need a record for them for the superclass, but we don't want to have a record for them in that subclass set, right? Because that would just be wasting space. Okay. All right. So let's go into the disjointed ones, the or. It must be, if it's one, it cannot be another. Okay. Mandatory or, meaning it must be one of the below ones, and it must be one of the lower ones, but if it's one of the lower ones, it cannot be any of the others. So I think that's this one. Yep, right. So we have owners. Owners exist. An owner must be a private owner or must be a business owner. Okay. So how do we do that? Many relations. One relation for each combined superclass subclass. So what we do is we have one relation for private owner, one relation for business owner. So in this example, the way that this looks is it looks like these three entities become only two tables or two relations. Okay. Now, you're probably thinking, as I would if I were in your shoes or at your computer desk or sitting in your bed right now watching this. I don't know what you're doing. You would say, wait a second. The last ER diagram, the one that we had before this, it had only two entities, and we changed it to be this 3-1. And you would be right. And you would say, well, why didn't we leave it like that? Because that represents the system better. That represents what the system actually looks like better. Remember that one of the benefits of this ER modeling stuff, one of the things that we're trying to do is we're trying to help our users, our customers, understand what our system looks like, right? And how our system behaves. So the problem is that with that other way of viewing it, required all this extra explanation for, well, we can't do this because this is the, we can only have one of these but not the other and stuff like that, and required all these like special notes being written and whatnot. Okay. Whereas with this visualization, this is easier for us as humans, and especially for our customers who may not be technical people. This is easier for them to understand. Okay. So we've got to do it this way for our customers, even though the actual system might look more like the diagram. That's harder for our customers to understand. I hope that's clear. I don't know if I can word that right now in my mind. I don't know if I can word that in another way that would be clearer. Okay. So let's look at the final one. Optional disjoint. So that means it's optional participation. If it doesn't have to be one of the subclasses. It can be just a normal parent class, or it must be one. If it is part of a subclass, it can only be part of one of them. It can't be part of more than one. Okay. So the way we're going to do this is going to have one relation for that superclass. So we're going to follow this optional idea up here. And we're going to have one relation for the superclass and then one for each subclass with a foreign key back to the primary key of the superclass. Okay. If we want to see it like this, right? So if we had mandatory non-disjoint, so all owners would be an example. So if we made it mandatory, mandatory and, right? Mandatory and can be more than one, right? So this would be how we would do that, one table. optional non-disjoint. It can be part of a subclass. If it is, it can be more than one. So then we have an owner table, and then we have an owner details table. Okay, I hope that's pretty clear. Mandatory disjoint must be one of the below ones, can only be one. So we have a private owner table and a business owner table. Mandatory or. Notice that is what this diagram is. Okay, that is what we ended up making. Okay, optional disjoint, meaning it can be a subclass, doesn't have to be. If it is, it can only be one. Okay, owner table, the parent, the superclass table, then each of the subclasses. Okay. All right, so let's talk about quickly complex relationship types. Okay, this is, let's see, I don't think that's what I'm thinking it is. I'm thinking of multi-valued attributes. So complex relationship types, those are the ones where you have 3 or 4 entities involved in a relationship. Read that, understand that. It kind of works like a many-to-many relationship, and so, but it's really kind of a rare thing to have this, and so I'm not going to go into great detail for that. Okay, but I do want to talk about the multi-valued attribute. So an example of a multi-valued attribute, let's see, they have one in here. Where was it? Okay, they did this somewhere else. There was another one they did where they did the telephone number. I think it was branch. I think it was the branch table where they had multiple options on telephone where you could have, for each branch, they could have 1 to 3 telephone numbers. Okay, so basically we treat this as a one-to-many relationship, right? Where you could have, the branch could have telephone 1, telephone 2, or telephone 3. Instead of having 3 separate columns, one for each telephone number, then why would you want to have that? Because the problem is, what happens if a branch only has 1 telephone number? Or what happens if the majority of our branches only has 1 telephone number? Then what you would be doing is you'd be creating these extra columns that would be definitely nulls. You would also be making your queries to get all of the data, to be able to get, like, if I said, I want the telephone numbers for all the branches that are in a certain city, for example, then you'd be making your queries much more difficult. Okay, so what we're going to do is, instead, we're going to create a new relation to represent that attribute, and we're going to include the primary key of the old entity in the new relation as a foreign key. Okay, so it basically acts as a one-to-many relationship. So what that would mean is you would end up in a situation where one entity in our ER diagram with a multi-valued attribute would actually be represented in our logical model as